So we've done some things with inline constraints, out of line constraints, naming the constraints. I want to show you the indexes quickly, just to show you a few key important issues. So I'm going to drop all the tables again by connecting as system drop user shows cascade. Well, let me. It says I'm currently connected because I'm connected in here. So I'm going to right click and disconnect. It won't allow me to drop the user if it's connected. Not with this command anyway. Drop user shows cascade. And I'm simply going to generate all the tables with a script I have, and I've just gone and regenerated that user. A script I have here. I'm just going to select the whole script. Don't worry about the content right now. Get this off the screen. Right click. So everything's named. Let's go to here. First of all, tables. Let's pick on the supporting act table. This is an interesting table. This table says it has two columns. Go into the constraints. It has a named primary key. Note that my primary key is named XPK supporting act, which was in my script. It has two columns because it references back to two parent tables. The primary key has two columns in it. And it has two foreign keys that point back to those two parent tables. Note that the constraints are named FK. This is standard practice with me. This is something that I do to keep myself organized. The primary key creates the index automatically, so the constraint name is used by the index name. So when I go into the indexes, I will find that I have primary key automatically named XPK, and the foreign key is the names that I've given them. I'm going to go back into my script again, in here, just to show you the supporting act table again. And here I have constraint XPK, primary key, constraint FK, and then I have to create an index on the foreign key. We have to create an index because Oracle doesn't automatically. Every time a primary key is checked against a foreign key, the foreign key table will be checked in its entirety. If you have a huge table, it will check the entire table to check every single row addition, say, to the supporting act table. So if you have 10 billion rows in the supporting act table, every time you add a new act show ID combination, that addition operation will actually go and check the supporting act table, read the entire table, to find out if that combination exists, because it can't create it if it already does. Therefore, you want to create these foreign key indexes on these tables so that when this table gets checked to find out if these values exist, it reads the index and not the entire table. If you've got a very large table, the indexes can provide a much faster search. Very important to create foreign key indexes. It can cause serious locking issues with your database in general and serious performance problems, and quite often it's something that a lot of people don't know how to find. Very useful piece of information that is.